Yeah, good evening everyone. Welcome to expected questions of GATE 2022. Yeah, good evening everyone. Right, welcome to expected questions of GATE 2022. So before going to start, just I want to say one small thing to all of you. I want to say one small thing to all of you, that is for GATE 2023 people or 24 people, GATE 2023 people, 24 people, right? Those people who want to prepare for 2023-2024 from 24th January onwards, TOC subject is starting. Please don't miss it out. GATE 2023-24 people from 24th January onwards, TOC subject is starting, right? Don't miss it out, right? It will start from 24th January, right? Please, if anyone want to prepare for 2023 or 24, you can join in this batch. Right? So that you can complete this subject as soon as possible, right? Let's go to first problem of today's class. Can you say what the answer of this? Which one of the following grammars is free from left recursion? Which one of the following grammars are free from left recursion? Can you check one time? Check what the answer of this problem. Which one of the following grammar is free from left recursion? Try once. Yeah, someone is saying, sir, GATE 2022 will be postponed. Oh, you want that? Please, right? Please remove this headache. Right? Complete as soon as possible. I will pray the God. It cannot be postponed. Oh, you want to spoil your life again? Please finish it off. My sincere suggestion, mostly don't postpone. If it postpone, it's okay. Mostly don't postpone. I will pray the God, don't postpone, so that all students will complete the exam. They will dance happily on the main road. They will happily dance on the main road. I wish exam will be over. Do as much as possible until exam. Can you guess what will be the answer of this problem? Which one of the following grammar is free from left recursion? Which one of the following grammar is free from left recursion? Left recursion means you know very well, right? Left hand side of this arrow symbol, whatever is there, right side also, left hand side, same person will be there. This is called left recursion. This arrow symbol, left hand side, whatever there, right hand side also, left place, that symbol only there, followed by something else. This is called as left recursion, right? I think if you observe clearly, see this one. Here left recursion is there, but he is saying free from left recursion. So it is having left recursion, it cannot be the answer. It is having left recursion, so it cannot be the answer, right? Then what about option B? What about option C? What about option D? Let's check what about option B? What about option B? S goes to AB, B or C. A replaced by A content, B replaced by B contents. So can you help me now? If I replace B by B contents, no problem. If I replace A by A content, no problem. If I replace B by B content, no problem. I think it don't have left recursion. Free from left recursion. I think option A, left recursion is there, so it cannot be the answer. Option B, left recursion not there. I am thinking B will be answer. Let's check further also. Let's check further also. Can you help me? S goes to A replaced by A possibilities. A replaced by A possibility. A one possibility is this one. A another possibility is this one. A another possibility this one. If I replace A by A possibility SC, I think S and S there. So indirect left recursion there. Here indirect left recursion. Here indirect left recursion. So left recursion means what? Directly left recursion or indirectly? No one bother. So in this problem, direct left recursion there. Here indirect left recursion there. Now let's see the option D also. S goes to B. A goes to BD or epsilon. B goes to AA or epsilon. Can you help me now? If I replace B goes to A replaced by A possibilities. A replaced by A possibility. One of the A possibilities is BD. So I think there is a left recursion here. So here also there is an indirect left recursion. Indirect left recursion. So right, option B is free of left recursion. A, C, D contain left recursion directly, indirectly. Answer is B. Answer is B. To this problem, answer is B. To this problem, answer is B. If anyone having doubt, let me know. When you say left recursion, it may be direct, it may be indirect. When you say left recursion, it may be direct, it may be indirect. Right? I think everyone got the answer for this problem. If anyone having doubt, please let me know. If anyone having doubt, please let me know. Yeah, let's see these also. Let's see this also. All India mock test for GATE 2022 people. All India mock test for GATE 2022 people. January 2 to 30, All India mock test is there for GATE 2022, right? So please enroll now. The advantage with this test is it is conducted by right, these questions are framed by Unacademy top educators, mostly error free. And one more, total syllabus will be covered. Experience the actual exam like setting, almost like final exam kind of feeling you will get. Get your All India ranking. So the advantage with this one is all India level, all the rankers are participating. All India level, all the students are participating. So all India rankers will be there. In those rankers, you can check yourself how much close you are. If any drawbacks are there, you can rectify. If anyone is not enrolled till now, please enroll. Please enroll. If you want to enroll, just scan this QR code, you can enroll. Every Sunday, right, 2nd January to 30th January, right, test, right, every Sunday test is going on. You can attend, you can enroll now. You can enroll now. Next one is Unacademy Combat you can write. Every Sunday at 11 a.m. Every Sunday at 11 a.m. Unacademy Combat is there. Participate in that Unacademy Combat. Get as maximum discount as possible. Up to 100% scholarship possible. And one more, 100 lucky participants will get exciting rewards also. Right? Use the referral code REDDYSAR. REDDYSAR live. You can use it. So on January 5th, these many batches are started on Unacademy platform. Right? For all the engineering streams, these many batches are started. These are also few more batches. For CSE batch, for CSE branch, Ascend batch is started. In this batch, I am teaching algorithm, data structure programming, compiler design and theory of computation for this batch. If you want, you can join in this batch. Use the referral code REDDYSAR live. One more batch, Eval batch is also started. You can join in this. Whichever batch comfortable to you, you can. Spark batch also join. Spark batch also started. You can join in that. Next one, Verve batch also started. Totally 4 batches are started. You can join whatever batch you want. Use the referral code REDDYSAR live. These are for GATE 2023 and 24. 23 also, 24 also. This is for 2024 batch. If you are preparing for GATE 2024, you can join in this batch. If you are starting 2023, you can join in this batch. 2023, you can join in this batch. 2024, you can join. Totally 4 batches are started. You can join whatever batch you like. Yeah. So can you see this question? Consider the following translation scheme. Consider the following translation scheme. S goes to ER, R goes to star ER or epsilon, E goes to F plus E or F goes to open bracket S closed bracket or ID. Some semantic actions also given. Within the brackets is semantic actions. Within the brackets is semantic actions. Here ID is a token that represents an integer and ID dot value represents the corresponding integer value. For an input 2 star 3 plus 4, this translation scheme prints. Can you check this? One SDT is given to this SDT, right? So if you give this input to this SDT, if you give this input, what will be the output? To this SDT, if you give this input, what will be the output? Can you check one time? Can you check one time? Can you check what is the answer of this problem? First, what you do is using the given grammar, right? For the given string, draw the tree. S goes to ER, first star required, next plus required, right? S goes to ER, right? First star required, first plus required. Let's see. Rough diagram I am writing. Rough diagram. S goes to ER, first star required. R goes to star ER. And one more. Where is the plus here? I think E goes to F plus E. E goes to F plus E. Yeah, I think you got it. I think E goes to F. F goes to ID. ID star, F goes to ID. E goes to F, F goes to ID. I think so. R goes to epsilon. This is from the given grammar. I have to generate this. 2 star 3 plus 4. 2 star 3 plus 4. 2 star 3 plus 4. S goes to ER, E goes to F, F goes to ID. R goes to star ER, E goes to F plus E. F goes to ID, E goes to F, F goes to ID, R goes to epsilon. Like this. Right? So from this input string, right? What kind of output is coming, we have to check. For the star goes to ER, no semantic action. For R goes to star ER, in between E and R, print star is there. E goes to F plus E, after E goes to F plus E, over plus is there. F goes to ID, after that one is over, print ID. So remember, F plus E, semantic action at the end. R goes to star ER, semantic action in between the E and R. Be careful. So I am starting now. Let's check here. S goes to ER. This is not over, but at the end also no semantic action. It's okay. And S goes to ER, to complete it one E required. E goes to F. F goes to ID. What is the semantic action? F goes to ID. After this production is over, semantic action 2 will be printed. First 2 printed. Then E goes to F, no semantic action. S goes to ER, E completed. Let's go to R. R goes to star ER, star completed. Right? E goes to, right, F plus E. So E goes to F plus E should be completed. In that F required. F goes to ID. I think 3 will be printed. So this is completed, right? After completion of this one, plus also over. Then E goes to F, F goes to ID. Here ID also printed, 4 also printed. After this is completed, this production over. Now semantic action plus will be here, plus will be printed. This is completed, then I will go here. There is no semantic action. R goes to star ER. See this one, R goes to star ER. Now see the answer. When you say E completed, first plus will be over, but in between there is a star also. You have to print star also. Because of E goes to F plus E, as soon as it is over, plus will be printed. When you say E completed, semantic action also completed, then R goes to star ER. E completed, then star required. I think 2, 3 plus star, 2, 3, 4 plus star, 2, 3, 4 plus star. I think D is the answer. First to plus, then star. 2, 3, 4 plus star will be printed. 2, 3, 4 plus star will be printed. Answer is fourth option. Please check if anyone having doubt. See the semantic action. One time verify semantic actions also. ID will be printed. E goes to F plus E, print F plus. Plus will be printed. But remember, plus will be printed after that production is over. After this production, E goes to F plus E over, then plus. Then when plus also over, this is successfully completed. Then star. So plus star, please be careful. Plus star, not star plus. Plus star, not star plus. Not star plus, please be careful. Answer is D, fourth option. Answer is fourth option. Answer is fourth option. Anyone having doubt, please let me know. Right, let's go to next problem. Let's go to next problem. Yeah, what is the answer of this problem? Can you check? What is the answer of this problem? Check once. Similar kind of problem. It is very easy comparing previous problem. Comparing previous problem, it is very easy because semantic action at the end. Semantic actions at the end. Semantic actions at the end. Semantic actions at the end. This problem is easy than the previous one. Previously semantic actions in between also. Now semantic actions at the end only. What is the answer? Semantic actions at the end only. First to draw the tree, S goes to AA, S goes to A, S goes to AA, S goes to AA, that's okay. A goes to SB, that is also okay. And S goes to A termination. And one more thing, input string is what? AAB. Input string is AAB. It's a very simple one. Input string is AAB. 2 times A required. I think it's very small past. Let's check here. S goes to AA. I think A goes to SB. S goes to A. AAB. S goes to AA. A goes to SB. S replaced by A. Right? Now see the how the semantic actions are running. Let's see here. S goes to AA. See this one, semantic action at the end, both are over then only. This is over, but this is not over. So A goes to SB, right? Both are over, then only I will go for semantic action. First S required. S goes to A. It is the first one going to be complete. So S goes to A, semantic action 2. 2 will be printed first. 2 will be printed first. 2. I think this cannot be the answer. This cannot be the answer. Either B or C. So this is completed. Afterwards A goes to SB. I think here 2 printed. Here 3 printed. A goes to SB. Here 3 printed. 2, 3. 2, 3. I think this is gone. 2, 3. Now this is also completed. Then S goes to AA, which is going to be 1. 1 printed. 1 printed. 1 printed. I think C is the answer for this. This is the easy problem. This is the easy problem. Answer is C. This is the easy problem. Answer is C. Previously, semantic actions in between. Now semantic action at the end. So it is very easy. It is a very easy. It is a very easy. Yeah, Ashtosh, it will happen. Ashtosh, it will happen, right? Don't think a little bit also negatively, right? Please do best work now. Please do best work now, right? In the first semester, normally like this only. Second semester, third semester, it will become so easy. Ashtosh, second semester, third semester, it will be very easy. First semester, so difficult. First semester, so difficult because of new atmosphere and right. So a lot of assignments will be there. It's really difficult, right? So whatever it may be the reason, you got 6.5. You could have get more. 6.5 you got, right? But second semester so easy. Work so hard. Work so hard. Some of my friends are there while studying. I'm in IIT. Some of my friends got 4.5. Still, after second semester is over, they got good percentage, right? You no need to feel demotivated. Please do great work in the second semester, right? Fine. Thank you so much for informing me. All the best. Yeah, can you go to the next problem? Can you go to the next problem? This is the next problem. Can you check once? Consider the following SDT. Consider the following SDT. S goes to open bracket S closure bracket S dot val is equal to S1 dot val plus 1. S goes to open bracket S closure bracket S dot val is equal to S1 dot val plus 1. What is the S1 here? Parent is S. Child is also S. To discriminate, let's keep child as S1. Parent is S. Child also S only. To differentiate, let's keep S1. Actually, here S1 is not there. They given the rename to differentiate the parent and child. So parent is S assume, child is S1. Left side person is S, right hand side person is S1. Actually there is no S1, all are S only. Last one S goes to epsilon, S dot value is equal to 0. What is the input? What input above SDT will take? That is the question number 1 which you have to answer. What kind of input above SDT will take? Right? Question number 2. What output above SDT will print? What is the input above SDT will take? What is the output above SDT will produce? Can you check once? I think someone is asking, sir, what kind of strategy to follow in the examination efficiently? What kind of, right, someone is asking, what kind of strategy we have to follow in the exam? My suggestion is, I think it is better to have 2-level hierarchy or 3-level hierarchy. While attempting the question paper, 65 questions are there. Instead of attempting in one round only, let's go for 2 to 3 rounds. 2 to 3 rounds. Don't stuck at one question, right? Whichever question, while going to the paper, first round is going to be, take the first round approximately 45 minutes. Approximately 45 minutes you take in the first round. While going itself, whichever problem you can do, please do it. This problem you can do it. Suppose some problem you can do, but it will take more time. Just mark it more time and go. Some problems you cannot do, cross mark. So one round, first round 45 minutes, what you do is, right, whatever you can do, directly do. Whatever you can do but taking more time, just mark it saying that more time. Some problems you cannot do, just write you cannot do. That is one round. In the second round, which problems will take more time, those things maybe you can do. That will also take, let us assume that it will take once again one more 45 minutes. Right? Lastly, those things which you cannot do, you can have a look. My suggestion is go for a 2 rounds or 3 rounds model. 2 rounds or 3 rounds. If you try only one round, the problem is you will take some places more time, some problems you may not study also. So my suggestion, go for minimum 2 rounds, maximum 3 rounds. It is my suggestion. Someone is saying postpone GATE 2022 till December. Why you want to do that? Why you want to do that? Then 2022 people, 2023 people, all people will participate and it will become very difficult to you. It will be very difficult to you. 2022 people, 2023 people, both will write. It will become very difficult to you. Let's go ahead now only. Whatever will happen in the next year GATE exam. It is my suggestion. Yeah, can you help me now? This particular SDT will take what kind of input? This SDT will produce what kind of output? I think if you observe clearly this grammar if you observe clearly, S goes to open bracket S closed bracket, S goes to open bracket S closed bracket, S goes to, you can take epsilon. What is the meaning? 2 open brackets, 2 closed bracket. One more thing, S goes to open bracket S closed bracket, S goes to square bracket S open bracket, right? Square bracket open bracket, square open bracket, square closed bracket. Again, right, you can do whatever you feel. You can do square S closed, S goes to epsilon, right? Which will goes to I think like this. Like this. I think this indirectly is directly saying that how many open brackets are there, those many closed bracket. So input of this problem is going to be, right, this SDT will take input as, let me write here, this SDT will take input as, right, so I think a balanced parenthesis, input is balanced parenthesis. This is the input. Output if you observe output carefully, if you observe the output carefully, output means semantic actions. If you see the semantic actions carefully, whenever open bracket closed bracket is came, S dot value is equal to S1 dot value plus 1. But S goes to epsilon, S dot value is equal to 0. What is the meaning? Whenever brackets came plus 1. I think it is counting, right? It is counting number of balanced parentheses. Output is going to be counting number of balanced parentheses. This is the output. Input is Balanced parenthesis it will take as input. Output is counting number of balanced parentheses. Suppose this example if you see, right? So square bracket, square open bracket, closed bracket, 1, right? Normal, right? Normal brackets, open bracket, closed bracket, 1 more. Square again, 1 more. Normal again, 1 more. Totally 4 open, 4 closed. Answer will be 4. For this one, if you see 2 open, 2 closed, answer will be 2. Here 4 open, 4 closed, answer will be 4. So input is going to be, right, set of balanced parentheses. Output is going to be counting number of balanced parentheses. So what is that problem? I don't know. If you send to me, I will explain. Srinivas, you send to me, I will explain. You send to me, I will explain. This is my WhatsApp number. You send to me, I will explain. Right, this is my WhatsApp number. You send to me, I will explain. Yeah, let's go to the next problem. Yeah, can you try this? What is the answer of this? Consider a stack S given below with the elements 1, 2, 3 along with the usual operations push, pop and top as shown below. Push, pop and top also as shown below. So stack already contain 2, 3, 1. First stack contain 2, next 3, next 1. Top of the stack 1 is there. Top of the stack 1 is there and 1 more. For the first production, this is the SDT. Second production, this is the SDT. Third production, this is the SDT. Fourth production, this is the SDT. This is the input string. This is the input string. Then they are asking the number of elements that will remain in the stack after parsing the input string and stack according to the above SDT rule is. The number of elements that will remain in the stack after the parsing of the input string and stack according to the above SDT rules is. Can you try this? What is the answer? One SDT is given to this SDT. If I give this input string, what will be the output is asking. For every production, one semantic rule also given. First production semantic rule is, right, S dot push 5. Second production semantic action is S dot pop. Third one is S dot top. Fourth one is S dot top. Input string is 1 divide 2 into 3 into 4. Grammar rules if you see, A goes to B star C. Next one, B goes to C divide D. C goes to A. B, C, D goes to ID. Stack already contain 3 people. Top of the stack is 1. Bottom of the stack is 2. Is asking the number of elements that will remain in the stack after the parsing of the input string and stack according to the above SDT rule is. So what you do is, using the grammar for the input string, draw the tree first. Using the grammar for the given input string, draw the tree first. I am repeating once again. If you want to give answer for this problem, using the grammar for the given input string, draw the tree first. Draw the tree first. Let's try. A goes to B star C. I think start symbol. You could have mentioned start symbol. He mentioned. Let's check. Is he mentioned start symbol? Consider a stack as given below with the elements 1, right? Below with the elements 1, 2, 3 along with the usual representations, usual operations push, pop and top as shown below. Stack S, the number of elements, I think is not given. When he not given, who is the top, who is the start symbol and all, take the first person as the start symbol. Right? A goes to B star C, B goes to C divide D. Yeah, I think we can do this. Let's try. A goes to B star C. A goes to B star C. Yes, I done. Right? Star already came. I think 2 stars required. A goes to B star C. 2 star and 1 more, 1 divide. B replaced by C or D. C divide D. Yeah, I think this is the current status, C divide D. That is also fine. That is also fine. I think C can be replaced by A. I want one more star, right? C replaced by A. Let's see. Yeah, I think two C's are there. You can replace anyone by A, but this C replaced by A is the better, because A goes to, right, B star C will come. Right, I think if you observe clearly, C divide D star B star C. Star, right, see this one. C divide D star B star C. I think it is fine. Now, if you observe terminals, if you see the leaf node, CD, BC. BCD, I think other than A, I think BCD. BCD goes to num. This is also num. This also num. This also num. This also num. So simple, very simple, very simple. Using the given grammar for the given input string, draw the tree first. Yes, I drawn. Yes, I drawn. After drawing the tree over, now we will see the semantic actions one by one. Now we will see the semantic actions one by one, right? Let's see one by one. Where is the semantic action? At the end only. For every production, semantic actions at the end, check here. For this production, semantic action at the end. For this production, semantic action. So at the end only semantic actions are coming. We will do that. So it is a normal, it is a bottom up parsing kind of thing. At the end only semantic actions are coming. Let's check. A goes to B star C. So to complete B star C, first B required. B goes to C divide D. To complete this one, first C required. C goes to num. Can you say C goes to num? What is the semantic action? S dot top. Right here, semantic action is S dot top. C goes to num, S dot top. Top means what? Already stack contain what? Can you see? It is a stack. Already stack contain 2, 3, 1. Stack already contain 2, 3, 1. It is the current, right? It is the stack actual as of now. So C goes to num, S dot top. The name of this stack is S. S dot top means 1 will come. But when you say top will come, it is not a push, it is not a pop. C goes to num means S dot top. S dot top is 1, is not pushing, is not popping, simply reading. So this is completed. C divide D, C over, right? Divide is over. Now come to the D. D goes to num. Here also, I think D goes to num, right? Semantic action is S dot top. Again 1, no use. So B goes to C divide D, it is completed. Then this is completed. B goes to C divide D. What is the semantic action? B goes to C divide D, semantic action S dot pop. Now pop. At this place pop. Then he is gone. Then he is gone. So A goes to B star C. B completed, star completed. Let's come to C. C goes to A required. A goes to B star C. First this will be. So B goes to num. What is the answer? S dot top, 3 will come. This is completed. This is complete. Let's go here. C goes to num. Right? S dot top. What is the answer? Again 3 will come. Now A goes to B star C. Because of both are over, now I can complete. A goes to B star C. What is the answer? S dot push, 5 will be push. This also completed. Now C goes to A. What is the answer? Again S dot top. Again S dot top. There is no use. Now A goes to B star C. What is the answer? A goes to B star C. What is the answer? A goes to B star C. What is the answer? Push 5. Again push 5. I think pushing once again. I think if you observe clearly, last one also completed. Now he is asking the number of elements that will remain in the stack after parsing the input string and stack according to the above SDT value is, right? Can you help me now? In the stack at the end, how many are there? I think 4 people are there. 4 people. And one more thing is, when push operation will happen, A goes to B star C, push, divide, pop. I think if you see the tree, only one time divide, 1 pop. Initially 3 there, initially 3 people are there, Because of 1 divide 1 pop, 2 are there. Because of 2 star, every star is push operation. Every star is a push operation. I think 3 people, you done the 1 pop, remaining is 2, right? 2 push operations you done, totally 4. It is a very simple answer is 4. It is a very simple answer is 4. Right? Initially stack contained 3 people, 1 pop operation you done, it became 2. Right? Afterwards 2 push operations you done, 2 plus 2 totally 4. 2 plus 2 totally 4. 2 plus 2 totally 4. Yeah, can you see this? So previous problem answer is 4. Previous problem answer is 4. Previous problem answer is 4. Check now, what is the answer of this problem? What is the answer of this problem? Someone is saying where we use input string, right? We don't use input string, but according to the grammar rule, we are using the semantic action. So indirectly we are doing, but directly we are not doing anything. Dushyant, we are not doing directly anything, but indirectly we are doing. Using the production only, semantic action is came. If production is not there, semantic action, which one you will take? Directly we are not doing, but indirectly we are doing. So to this problem, what is the answer? Consider the following SDT. Consider the following SDT. A goes to A, B, C, D. A dot I is equal to B dot I. C dot S is equal to B dot S. B dot S is equal to C dot S. So if you see A is a parent, B, C, D are the children's. So parent is getting from children. So I think parent getting from the children's means it is a synthesized. It is synthesized. Right? Next one, child is getting from sibling. C is getting from the sibling. C is getting from B. I think it is going to be inherited. B is getting from C. B is getting from C. It is a inherited. B is getting from C. It is a inherited. It's okay. It is inherited, it's okay, but it is also inherited, but in this inherited, if you see from the left child, left one you can take, from right you cannot take, but he is taking from right. Left is allowed, inherited left is okay, inherited from parent also okay, inherited parent okay, inherited left also okay, but here inherited from right not allowed, right, because of this one, right? So everyone now L attributed definition is failed. Here, right, S satisfied. Synthesized attribute means what? S attributed definition. It is a S attributed definition. S means L also. It is a L attributed definition, but not S. So till here if you see L, first one is, right, first semantic action is, right, S attributed also, L attributed also. Second one only L but not S, but third one L also gone. Overall nothing is the answer. L attributed is right until second one. S attributed is right. First one is S attributed. Second one is not S but L. Until second one L satisfied. Until second one L satisfied. Only first one S satisfied. Until second one L satisfied. Right? So by reading the third one I got to know that no one satisfied. Answer is D, none of these. Answer is D, none of these. right, fine, perfect, perfect, perfect. Yeah, this is the problem. This is the problem. Consider the following flow graph. This is the flow graph. Consider the following flow graph. This is. Consider the following flow graph. This is the flow graph. Now he is asking which one of the following is correct. In of 2, out of 2. In of 1, out of 1. In of 4, out of 4. In of 3, out of 3. Means in this diagram, for first basic block, second basic block, third basic block, fourth basic block. I think 5 not required. See, 5 not required. First basic block, second basic block, third one, fourth one. For all of them, can you find out in and out? First basic block, if you want, I will give the number. See, first basic block, second basic block, third basic block, fourth basic block. For all these 4 people, can you find out in and out? That's what he is asking. For all the 4 people, can you find out in and out? I will give answer before me. Can you try once? One, two, three, 4. Can you find out in and out? And one more thing, while finding in and out, start from bottom. Start from bottom. This is called bottom up analysis, backward approach. This is called backward approach. Bottom up analysis, backward analysis. This is backward analysis. Can you do once? Start from exit. Start from exit. It is a backward analysis. Start from exit. Good evening, good evening. Four basic blocks, 1, 2, 3, 4. Find out in and out. For the first one, in and out. In and out. For the second one also, in and out. For the fourth one, in and out. For the third one also, in and out. Lack of space I am managing. Careful, careful. For the fifth one also, in and out. Fifth one also, in and out. Exit also in and out. Can you guess? Can you guess? Exit, what is the in and out? Exit, what is the in and out? So everyone know, right? So start from exit, right? Exit person, right? Everyone know exit person out is going to be pi. Exit person out is going to be pi. So let me use different color so that you will get some clarity. Right? Next one, exit person out is going to be pi. Can you say what about in? Exit person out is going to be pi, it's okay. But what about in? You know very well. In is nothing but out minus kill union gen. Out minus kill union gen. I think here what is the answer? Out is pi minus anything is pi only, union gen nothing there, so pi. That's okay. So exit person, in and out you got, that is fine. Can you go to before him who is there? Before him who is there? I think B5 is there. Before exit B5. Let's start now. Out of this person is going to be, out of B5 is going to be next person in, which is pi. B5, out of B5 is going to be next person in. In is anyhow already pi. Can you say what about in here? What about in here? B5, what about in? Out minus kill, union gen. So what is the answer? Out is going to be pi minus kill. Kill is x only, so pi only, right? Union gen. Answer is going to be, I think, x comma q. X comma q. That is completed. I think B5 is completed. B5 is completed. Let's go to B4. What about B4 in and out? What is the out? Out of this person is going to be in of next person. What is in of next person? XQ. Out of 4 is going to be in of next person. In of next person is going to be XQ. Yeah, same. Can you say what about in of this person? Out minus kill, union gen. Out is right? Out is XQ minus kill Q. XQ minus Q is X. Union gen. What is the answer? Right? I think QQ cancel, X is there, union gen. Right? I think this answer is going to be X also, A also. That's it. Then what about this person? Right? In and out. What about this person? Out of this person is going to be in of next person. What is the next person? I think B5. XQ. What about in of this person? In of B3 is equal to out of 3 minus kill of 3. I think XQ minus W is XQ. Union AB. XQ AB. Right? That's fine. So B3 is completed. Let's go to B2. So out of 3 is equal to in of next person. Out of 3 is equal to in of next person. I think he is having 2 people. Out of 3 is equal to in, out of 2 is equal to in of 2, in of 4. XQAB. Left side. Right side is going to be XA. I think same. XQAB. Union you have to do, I done. Left side is XQAB, right side is XA. I think XA is common, so XQAB. Fine. What about in of him? In of him, this person is nothing but out minus kill. XQAB minus kill. So BC. So B is gone. XAB, right? XQAB. So A cancel. XQB. Union C also. So it is going to be XQ. I think A is deleted already. BC. Yeah, fine. So I think one round we done. We should do one more round also because cycle is there. We should do one more round also because of cycle. See, cycle is there, so we should do one more round. Everyone know. One more round we have to do. Let's start again from bottom. Because there is a cycle. See, there is a cycle. When whoever is participating in the cycle, you should do one more round. Cycle not there, one round enough. Cycle is there, 2 rounds you have to do. Let's start from bottom. Exit is okay, that's okay. Let's go to B5. Here onwards some problem is coming, right? Let's do second time. Let me change the color also, otherwise you may face some difficulty. let me change some color also. I think which color I can take. Let's go for this. Let's go for this. Can you help me now? Can you go to B5? Means I5 O5. I5 O5 require. Let's see this one. Right? So out of 5 is equal to in of next person pi only. See everyone, there is some difference. Everyone listen. Out of 5 is equal to in of next person. But when you see out of 5 is equal to in of next person, right? For the 5 next person is exit, that's okay. Out of 5 is equal to in of next person, that is pi, okay. But out of 5 is in of 2 also. Out of 5 is equal to in of 2 also. What is the in of 2? We are already done. What is the in of 2? We are already done. It will goes to xq bc. Out of 5 is equal to in of next person. Next person, if you see b2 also next person. For b2, what is the in? xq bc. Careful, xu bc. Next one, what about in of 5? In of 5 is equal to out of 5 minus kill of 5. What is the out of 5? xq bc minus x. So remaining is qbc. qbc union x. So it will become right, x remove qbc union x also, xqbc. That is the right I5. That, yeah, I think 5 completed. Let's go to 4. Out of 4 is equal to in of next person. In of next person, it is going to be xqbc. Out of 4 is equal to in of next person, xqbc. What about in of this? In of this is equal to out of this minus kill. Means out of this what? xqbc minus kill, q cancel. Union gen ax, a also, x also, x already there, so a xbca. Right, fine, like that. Next one, I think 4 complete. Let's go to the 3. Out 3 in 3. Out 3 is going to be in of next person. Out 3 is equal to in of next person. Who is the next person? 5. What is the answer? xqbc. What about in of 3? In of 3 is going to be xqbc minus xqbc, right, minus w, I think no use. Afterwards a comma b, I think a also added. So out minus kill, xqbc minus w is xqbc only. Union gen also, a comma b already there, a also added. So I think B3 also completed. Can you go to right I2 and O2? Let's see. O2 is equal to in of next to. O2 is equal to in of next to. I think 2 next people are there. 2 next people. Who are those? Out of this one is equal to in of next to. Next people are 3. I think xqabc. Union, one more also there, 4 also there. xqbc, I think same. Let's go to the next one. In. What is the answer? Right? So O2 minus a. xqabc minus a gone. Add bc. So xqbc. Right, xqabc minus a gone, union BC. I think XQBC. XQBC. Next one, let's go for B1. Let's go for B1. See this one, let's go for B1. In 1, O1. What is the O1? O1 is equal to, right? In of next to. What is the answer? XQBC. What about in of 1? In of 1 is equal to XQBC minus AB. So B cancel. Union BC. Union BC. And XQ also. Yeah, I think XQBC is in, XQBC is out. So this is, I think many people done. In B2 there is a cycle. Yeah, that is the reason I done 2 times. Let's go for right, O1 I1. So I1, if you see XQBC, O1 also XQBC. Let's check. Right, XQBC, I think this is satisfied. I1, O1 satisfied. Remaining people are not satisfied. Verify. Remaining people not satisfied. Verify one time. Only B satisfied. Remaining people are not satisfied. So O1, I1, XQBC. O1, right? O1, right? O1 and right? O1. So I am repeating once again. I1, O1 is going to be XQBC. Only second option satisfied, remaining things are not satisfied. Check properly. Backward analysis. This is called backward analysis. So this is going to be XQBC. This is also XQBC. Verify. And one more, in the case of the B1, no need to do 2 times because it is not part of the cycle. In the case of the B1, no need to do 2 times, 1 time enough. But in the case of other things, you have to do more than 1 time. In the case of other things, you have to do more than 1 time because there is a cycle. There is a cycle. If anyone says, sir, can I do 3rd time? Please check 1 time. Mostly not required because second round itself will give clarity. That if you want, you can do more than 1 time required because of cycle. So answer for this problem is B, second option. Second option. Yeah, can you go to the next one? Which one of the following statement is false? Check 1 time. Which one of the following statement is false? Which one of the following statement is false? In statically typed languages, each variable in a program has a fixed type. In a statically typed languages, each variable in a program has a fixed type. In untyped languages, values do not have any types. In dynamically typed languages, variables have no types. No, wrong. In dynamically typed languages, variables don't have type is wrong. Variable types are keep on changing. In dynamically typed languages, variables have no type. It is wrong. Because variables are having types but they are keep on changing. In statically typed languages, each variable in a program has a fixed type. True. Static means same, once only. Static means one only. In untyped languages, values do not have types. True. That is the reason untyped. In all statistically typed languages, each variable in a program is associated with the values of only a single type during the execution of a program. I think A and D same. A and D same, right? B different, but it is true. So C is wrong. dynamically typed languages, variables have no types is wrong. Variables types are keep on changing. So C is the wrong option because he is asking false. Right? Fine. So this one if anyone not getting, this one if anyone is not getting, this one if anyone is not getting, nothing there. See, nothing there. See this one. See everyone now. See everyone now. In of 3 is equal to, out of 3 minus kill of 3, union gen of 3. Just apply this formula. Out of any person is equal to, in of any person is equal to, out of that person minus kill of that person, union gen of. Just apply this formula, nothing. If cycle is there, apply. If cycle, apply cycle part more than one time. More than one time. If cycle apply cycle part more than one time. This is the only thing which you have to take care. Just apply, right? In of any person is equal to out of that person minus kill of that person, union gen of that person. If cycle, apply cycle part more than one time. Please remember, automatically you will get it. It is a backward analysis. Yeah, can you see this also? Consider the grammar rule E goes to E1 minus E2 for arithmetic expressions. The code generated is targeted to a CPU having a single register. The subtraction operation requires the first operand to be in the register. If E1 and E2 do not have any common sub-expression, in order to get the shortest possible code. If E1 and E2 do not have any common sub-expression, in order to get the shortest possible code, then what should be the answer? Can you check once? Vicky is saying postpone gate, sir. Why you want to do that, Vicky? Why you want to do that? Let's complete the gate exam. Afterwards we can enjoy. What is the answer for this? The code generated is targeted to CPU having single register. The subtraction operation requires the first operand to be in the register. If E1 and E2 do not have any common sub-expression, in order to get the shortest possible code, so what should I do? No common sub-expression means you can do any one anytime. You can do E1 also first, you can do E2 also first, because there is no common sub-expression, nothing common. If something common, I have to do this first, then only I have to do this, some relation like that. Because if nothing is common, you can do any one first. Nothing is common. And subtraction operation needed first operand to be in the register. So what you do is, because of anyhow E1 want first and all. First to do E2, then afterwards do E1, then finally do operation. Suppose if I do E1 first, I will do E1, next I will do E2, again I have to take E1, because to do this subtraction operation, right, E1 should be there first. Then what you do is first to complete E2, then do E1. E1 is there in the register, directly do subtraction, right? I think E2 should be executed first is the better answer. E2 should be evaluated first. So B is the answer for this. Otherwise taking E1, afterwards again taking E2, again E1. So first to do E2, then E1, then do subtraction. So I am doing. So suppose if you do anyone do E1 first, then after E1 you should do again E2. E1 you should be do and E2 also. E1, then afterwards you are doing E2. What is the meaning? E1 went to the main memory. Again E1 is came, then subtraction. Suppose if you do E2 first, after E2 then E1, then subtraction. If you see here, I think 4 lines code, here only 3 lines code. So do E2 first. Do E2 first. Do E2 first. I think this is the last year gate problem. I already given formula also. See this one. Consider a basic block that consists of 2 statements, S1 followed by S2. S1 followed by S2. S1 followed by S2. Then can you help me now? If S1 is followed by S2, please help me to this person. What is out of 1? Out of 1 is equal to in of 2. Out of 1 is equal to in of 2. Out of S1 is equal to in of 2. I think answer is A, direct. Out of any person is equal to in of next person. Out of any person is equal to in of next person. This is the last year gate problem. See how much easy it is. Just knowing the basics. Out of any person is equal to in of next person. Out of any person is equal to in of next person. Right? Careful. Yeah, can you see this also? Consider an ambiguous grammar G and its disambiguated version D. Consider an ambiguous grammar G and its disambiguated version D. So there is a one ambiguous grammar G. To this grammar, right, disambiguated version is D. Ambiguous grammar is G. Its a disambiguated version is D. Ambiguous grammar is G. Its a disambiguated version is going to be D. Disambiguated means unambiguous. Its unambiguous grammar is going to be D. Careful. Now he is asking, language of G is L of G. Language of D is going to be L of D. Then what is the relation between them? I think both are equal. The reason is languages are same. In the ambiguous grammar, multiple ways possible. In the disambiguated grammar, only one way possible. So both will be equal. Language will be same. Ambiguous grammar is G. Its disambiguated grammar is D. Right? Ambiguous grammar is G. Its unambiguous grammar is D. Language of G is L of G. Language of D is L of D. What is the relation? Both are equal. But in the first one, for a particular string, more than one tree possible. But here, only one tree possible. That is the only difference. Answer is C. He is talking about a specific grammar. He is talking about a specific grammar. All the grammars he is not talking, a specific grammar. Consider an ambiguous grammar G, not all grammars. Consider an ambiguous grammar G, its unambiguous grammar is D. Language of G is L of G, language of D is L of D. What is the relation between them? Both are equal. Both are equal. It's an excellent problem. Please take care. It's an excellent problem. Please take care. Yeah. So we'll see it remaining problem tomorrow. See you tomorrow. Good night. See you tomorrow. Good night.